Hello, what's up, guys? Today, I'm going to be starting with a series of lectures in mathematics where I'll be discussing indices. And for your next exam, whether you are writing the WAEC exams, O-level exams, the UTME exams, post-TME exams, you will need a solid knowledge of indices. And in this introductory aspects of indices, I'll tell you all the overview things you need to know. And then from there, I'll now discuss the laws of indices. So that's what I'll do there. Then in the second and subsequent videos, I will solve thought questions from all the past questions that have ever been said from the JAM, from the WAEC, from the O levels, from the school internal exams. You can name it. I will solve all of them for you. So let's begin with indices. Now I give example. What is an example I want you to know? Look at something here. Let's say we have 2. Let's say we have 2 times 2 times 2 times 2. What does that give me? This will be 2 times 2, 4 times 2, 8 times 2, 16. Now, but we can shorten all of this into that. There are how many 2's here? There are 1, 2, 3, 4 2's. Let me give another example. Say 3 times 3 times 3 times 3 times 3. I want to draw your minds to something so you can understand indices for a lifetime. So 3 times 3 times 3 times 3 times 3. This is 1, 2, 3, 4, 5. That is 3 in 5 places. I put it as a superscript. Or let me give with letters. A times A times A times A times A. This is how many? 1, 2, 3, 4, 5. Maybe if I put another one, say times another 8. This is A into 6 places. Now, all of these ways in which I have written something as explicit as this in a shortened form is what we call indices or index notation. So when you hear me talk about index notation, I'll be talking about shortened forms of what? Of factors, which could either be doing maybe multiplication or what are you, but shortened forms. This is what we call index notation. Once it has been shortened, it is called index notation. Now, there is a rule of thumb that I want you to never forget as I'll be discussing everything here in indices. Now, what do I mean? I mean that if I give you A to the 6, 3 to the 5, or 2 to the 4, all these numbers that are written at the bottom, we call them the base. And then all these numbers that we write them as the powers, we call them the powers. The numbers that we write as superscript, we call it powers. So let me give an example. A to the 6, where A should stand for what? The base. And 6 should stand for what? The power. Why I'm saying this is so that as I keep studying or as I keep solving questions, I'll be mentioning A, I'll be mentioning base, I'll mention power, I'll mention base, I'll mention power. You should know what that means. You should know that A is the number we write below. That's the base is the number we write below, and the power is the number we write above. So the base carries the power. It's something you must remember. So I want us now to appreciate it. So this is the most introductory aspect. So at any time you be hearing me talk about indices, talk about index notation, I'll be talking about where we have shortened factorials. We have shortened them together. And I also mean something that has a base and that has a power. Okay, so let's now answer. There's the code now. What are the major laws that are going to govern it? Because it's the laws that if I discuss the laws, I'll be able to solve any question in indices. Let me begin with the laws. The first law is the multiplication law. What does multiplication law say? Now watch something. If I give you a question that says 3 to the 5 times 3 to the 7, what would be the answer to this question? It's a very basic something. Now, multiplication law says if you are multiplying one index and another index notation, this is an index notation, another index notation. If you are multiplying one index notation with another index notation, you should be able to add only their powers, especially when they have the same base. This law only works when it is the same base. Please leave a comment there. I'm putting so much energy to really explain this to you. I say that the law of multiplication under indices says that when two multiples are done, when two multiplication are done, where they have the same base and we are multiplying them, we are going to add their power. So this is going to be 3, 5 plus 7. The answer becomes 3 to power 12. That is it. So this rule of multiplication, I'll simply put it here that says that A to power B times A to power N, it should be AB plus N. I have just used now letters to explain it. I have said that if they have, it only works when it is the same base. That the same base, we do what to power, we add the powers. Okay? Yes. Now, for the next one, which is the division law. Division law says that if I have, let me give you the same thing again. Now, watch again. If I have 3, so let's say 4 divided by 3, let's say 2, the law says that they must have the same base. Because they have the same base, what do you do to the powers? You are going to subtract their powers. If it is multiplication law, add the powers. If it is division law, subtract the powers. So what that means is going to be 3, subtracting the powers, 4 minus 2. This will be 3 to power 2. So what have we learned from multiplication law? I put it again here. For law number 1, for multiplication law from there, it says that if we are multiplying two numbers, let's say A, 2 that have the same base, but different powers, say B here, say C here, and it is multiplication. Multiplication law says simply add it. It is going to be B plus C. So that's the first law I've stated now. These are examples I've used to illustrate it. Second one says if you take A, B divided by A, C, subtract their powers. A, B minus C. Now what becomes of the third one? For the third one, it is power law. Now what does power law means? Let me show you that here. For power law, we mean that because if you have a firm knowledge of all of these laws, solving any question here becomes easy. Power law says that if we have 3, which was raised to power 2, and all of this, raised to power, let's say 4 here, how do you solve something like this? Power law tells you that you are going to take the brackets inside and multiply. So multiply 2 powers. This is going to mean something like this. 3, 2 times 4. This is going to be 3, 2 times 4 is 8. So I say that formula for power law says if you have an index notation where we have a base and a power, and all of this still taken again by another power, what does that mean? Multiply their powers to open the bracket. So in opening the bracket, the power does not affect the base, but it affects the power. So power, and then when we do the multiplication of it, you get that answer. So A power B, all these raised to power C becomes A, B times C. These are laws. You go through over these laws many times till it becomes your own. Till you become a master at it. And then once you get it correctly, you now can be able to solve all the questions I'll bring your way. You help me, we solve the questions together. It makes the most sense. Okay? Now for the fourth one then, which is power law, which is product power law. Now for the product power law, I call it product power law because, let me give an example. If I have two numbers inside, say B, say C, all of these raised to the power n. What does this mean? This means for you to open bracket, this power should affect both numbers. Let me give you an example. Let me use an example in real life with real numbers so it makes sense. Let's say we have 3 here power n. What does this mean? For you to open bracket, this base will be affected by this power m. This other base will be affected by this power m. Remember, when two numbers are written together like this, there is a hidden multiplication sign there. So when next you see 2x, it means 2 times x. When next you see 4x, it means 4 times x. When next you see 3q, it means 3 times q. So when two numbers are written together without any sign being shown in between them, it's a product. That's why that thing says a product first. Then the second say the power. So it's called product power because two numbers which are product of themselves, then with a power. What do you do in such a situation? Let the power affect both base. So we're going to have 3 raised to power m times q raised to power n, because I said whenever there is no sign shown there, plus minus, imagine that there is a multiplication number there. So 4x means 2 times 2x means 2 times x, 4x means 4 times x, 3q means 3 times q, 6y means 6 times y. So 3q power n, product of two numbers with a power. What will you do? Let the power affect both base. So I'll put that one here, number 4. That when we have, let me use the letters so it makes sense that it can affect any numericals. So let's say we have AB, all this raised to power n. It becomes A n times B n. That is it. Now the next one there is the zero index. The zero index. Now this one is something everyone usually knows. Okay, it's something, even if you don't review these things again, you should know that anything raised to power 0 is 1. Anything raised to power 0 is 1. So 50 raised to power 0 is 1. 100 raised to power 0 is 1. 1000 raised to power 0 is 1. Anything raised to power 0 is 1. So that law is very simple here. I'll say a to power 0 is equals to 1. Then the next one. The next law is the negative index. The negative index. For the negative index, we mean when we have, say, b raised to power minus 1. Let me give a numerical example. Say 4 raised to power minus 2. Now, this law says that for you to remove this negative sign, do an inverse. Let me show you. Remember, 4 means 4. When you have a number, let's say 2, it simply means 2 over 1 because 2 divided by 1 is 2. So whenever you see a number without a denominator, it indirectly means it is divided by 1 because anything divided by 1 is that number itself. So 2, if I just wrote 2 here, 2 means what? 2 over 1. If you mean 4, what does 4 mean? 4 over 1 because 4 over 1 is 4. So 4 to power minus 2, what does that mean? That means 4 over 1 here like this. So invert it. When you invert it, you are going to have 1 over 4. Now, but because you have inverted it, it changes the minus now to become positive. So this is it. So negative index says that whenever I see a negative power, once I take the inverse fraction of it, it becomes positive. So I put that law here, number 6. The law says that if we have a to power minus n, this can be written as 1 over a to the n. Yes. And the last one, which is fraction law. Fraction law, what I'm going to see in this one is that imagine I have, let's say, 4 raised to power half. What does that become? It means something. It means that I'm going to have something like this. The square root of that's 4. Square root means 2. This has meant something for us. Let me state the law and then I'll show you what that means. It's a little bit tricky. Watch. If you have b over n, what this means is that this n will be taken as the root of a. That means the n comes here as a root, and then these all to power b. That's very important. So it means that if the n was 4, that's the 4th root. If the n was 7, that's the 7th root. It's very important. So the law says that Take the numerator of that fraction as a multiple, that means as a new power. But the denominator, what will you take it as? Take it as a root. So look at this one now. The numerator here is 1. So everything should be by 1. But the denominator is 2. That's square root. Square root is 2. Cube root is 3. Then fourth root is 4. Then fifth root is 5. And then like that. Okay? So it means you take the square root of that number. Let me give another example again to really illustrate this again. So take this example now. You see if you can do it with me. 9 to the power 2 over 3. Pause the video and try and attempt it first. What does that mean? It means something. You take 9. This is a third root. That's a cube root. And then the 2 means that you take everything somewhere. That's it. Let me give one more example and then we call it off on this aspect of it. Now, let's say we have 16 and 4 over 5. What do you think you'll do? You are going to say, you can pause and try. You are going to say 16. The denominator is 5. That's the fifth root. The numerator is 4. That's multiplying everything by 4. So this becomes the seventh law. Okay? So this is seventh law. So this is it for all the laws, the major laws that I want you to note for indices. Go through this video, write these laws down, and then you now stick it somewhere so that whenever we now start solving questions, because in the next video, I'm going to solve as many questions as my hands can lay on indices. So with this, I call it off. Please kindly like this video. Subscribe to this channel. Give me there a comment, thumbs up for me. It really encourages me to keep showing up for you and giving videos like this that will really help you. Until then, see you next time. I'm your friend, Agba Ene. Bye.